Guten Tag. Thank you very much for welcoming me at droidCon Berlin. So many of you would have known me from Wear OS, and I'm the lead developer advocate for Wear OS, our smartwatch platform at Google. So today I'm going to talk about three things. First, how does Wear OS use machine learning in our own product, and what are the user stories that we can share with you. Second, integrating ML things. If all things goes well, then I'll be live coding this portion, and hopefully it will compile and run on this very little thing called Android Things. And then number three is I thought, hey, ML Kit is just too easy to use. What else can I do? So I went down the rabbit hole of training my own model using TensorFlow. So I would kind of hopefully have time to share that as well and some of the lessons learned. So what it was one of the first things that we did with machine learning with Wear OS. So the first thing that we recognize is Wear OS as a platform have a very limited screen real estate, but at the same time, user really wanted this rich input into the platform. And one of the first projects that we did was to actually partner with our keyboard handwriting team in Zurich, between London and Zurich, to come up with this emoji recognizer. So how does it work? We take around 5,000 plus features from the user, so there'll be strokes, pressure, the order that the strokes are done, and then we turn it into around 2,000 plus emojis. And in this one, the lessons learned here is sometimes when we are not confident about one particular emoji, actually picking the top 3 or the top 5 for the user is super helpful. So we train using around 250,000 sample, basically very, very hard work from your Google engineers, donating their engineering time to draw emojis for us. That was one of the really popular features that we have back at I/O 2015. So what did we do next? The next thing that we did was implementing smart replies in any notification that comes to the watch. And here we're partnered with Google Research, or now known as Google AI, on the first on-device machine learning model, and basically really help to build the first TensorFlow Lite model and deploy it to real users. And this also resulted in one of the first. So Google's first what it means is simplified Chinese on-device TensorFlow Lite model is now available for our users in mainland China. It does not require any network connection. All the inference is done on the device itself. So how do you do this? If you want to go the hard way, then there is a paper that we published called ProjectionNet. And here's one of the simpler diagrams and simpler equations that you will find in the paper. However, you're all Android developers. So what have we done? Just one line of code. So in your notification, all you need to say is, hey, set allow generator reply equal to true. Then we'll just do that for you. So on your phone, when you are sending a message, when we bridge them and we see this, then we go, oh, we could just put smart replies underneath. No need to send, again, just to repeat, no data is sent to Google, and everything is done on device. So that's kind of Wear OS. The next thing that I'm going to talk about is what we just launched at I/O this year, ML Kit, and it's currently in beta, and it provides a number of functions. We're launching with 5 functions, and then smart replies in your app is basically coming. So the 5 that we'll launch are landmark recognition, image labeling, text recognition, face detection, and barcode scanning. And you will see that below each one of those categories, I've put a cloud and a phone next to it. So the one with the cloud is the ones that are relying on Google Cloud Platform, and the inference is done on the cloud. And then the one with the phone are our on-device model. So you can use it in an offline manner. So today, I'm going to hopefully code using the image labeling API. And here's the difference between the two versions, the on-device and on-cloud. So with on-device, you have very low latency, but at the same time, the number of labels is relatively limited, so around 400 labels. If you're coding in the cloud, we give you a high accuracy and also 10,000 plus labels. On this one, we actually will basically implement updates of the model as time comes, so you hopefully get better and better results over time. So what did I do? I took the Android Things image classifier Colab, which looks like this. And first of all, I implemented it. So it thought I looked like a lab coat, a bullet train, and a beaker on over there. And then I just plug in the ML Kit API, and it looks like the other one. So what does it actually look like in code? Live coding time. Fingers crossed. Cool. So in this particular example, I just kind of capture the image from the camera, turn it into a bitmap, and then put it into this particular method. So the first thing is basically specifying the option that you want to deal with. So in this case, Firebase vision label options dot builder. Close it. And then one of the options is to, as you can see, the top one, set confidence threshold, and you specify a float. In this case, I will put 50%. So it will return labels that are at least 50% confident, and then just build. Next, we need to turn the image that we have, the bitmap, into a format that Firebase understands. So file, image, equal, Firebase, image, vision, image, dot. So you can see that you have different options. So I'm going to use the one from bitmap, but you can also see that you can feed in a camera image or a byte array. It depends on the different options. So I'm going to, if I can spell correctly, bitmap. Yay. One more thing to note is that this particular API assumes that your image is upright. And you have the option to turn it by 90-degree increments. And they are basically constant value that are specified within the API. You will not be able to rotate it in an arbitrary kind of manner, but just something to be aware. So this thing. Next. Get the detector. So Firebase vision. Dot get instance. And the particular one that we want to get to is the get the vision label detector, feeding in the options that we've created, so specifying the confidence level that we want. And this should be, and then the step 4 should be very familiar with a lot of you, where we're basically just going to add the on success and on failure listener. So on detect, in image, dot add on, I want to say success first, not failure. Success, great. And then what we'll get is a bunch of labels. So for label in labels. Perhaps I should have chosen better names. Tag. This is one of my favorite features in Kotlin, which is the string template. So I could just very easily log label.label and confidence, label.confidence. And then I will update status. I've prepared earlier something to convert the result into text to be displayed, and I will display it in the default color. And then after that, I will also add a failure listener. Oh, actually, one more thing. Just want to turn the end processing to false, so we've finished the processing. In this, I want to log.d failed, boo, update status, failed, and then the color, default color, and end processing equals false. So hopefully that will work. So just to review, we have created the option. We have translated the image from a bitmap to a class format that Firebase understand. Get the detector, and then set the on success and on failure listener. So let's see if it works. So run the app. So hopefully it will run here, and as it kind of built and deployed down here, I'll just go through kind of what is different if you use the cloud version of this. So you can see that in the options, there are two options that are quite different. So as you can see, you can set the maximum number of results being returned. Here is 15. Because the model actually recognizes over 10,000 labels, if you set that confidence level to 0, like in the last one, it will return you 10,000 different labels. And of course, you would not want that kind of traffic kind of coming back. So one of the specification here is the maximum result. The other one is you can specify which model type that you want to use. So there are two options here. One is specifying the latest model. The other one is specifying the stable model. Really depends on what you want. So let's see if that got deployed. Yes, OK. So let's see if by the magic of Hangout that I can show you what is happening. Oh. Great. Yay. OK, so I specify essentially 3 buttons, and A is basically the TensorFlow model that comes on default, by default, and B is the ML Kit model that we just coded. Let's see, ML Kit logo. Okay, tie, I don't have one. If is 83%. Jacket, 68%. Smile, 64%. That's pretty good. Fun, 59%. And a selfie, 50%. So you can see that that kind of works on the local model. And let's try the cloud model. So the cloud model is saying person, 94%, finger, 71%. So here, vision care, 65, glasses, 60%. So you can see that the accuracy here is higher, and it also have a lot more different kind of labels in this one. So those are the ML Kit color demos. So back to the presentation. How much time do I have? Let's see. OK. So I thought, hey, that was too easy. Maybe I should do a little bit more. So I went down the rabbit hole of actually exploring in TensorFlow. And I was really inspired at the Android Maker event in Paris, where one of the presenters said, hey, in this American comedy show, they have this hot dog or not. Why don't we do strawberry or not? We're European after all, and strawberry is healthier than hot dog. So I go, yes, why don't we do that? Let's try it. But then the first thing that I realized is actually there's a pre-trained model called MobileNet, and strawberry is already one of the category they recognize. In fact, category 951. So it would be pretty boring in this talk and say, oh, if you just do the confidence level above a certain threshold, and if it is, then it's strawberry. If it's not, then it's other. So I thought, OK, let's do something else, something that the MobileNet model do not have. So I go, hey, why don't we do a Hoi or not? And hence this hashtag, we are Hoi, for this talk. And what did I do? So I go to TensorFlow for Poets. So the whole Colab is about classifying different types of flowers. And I put my face into it. So live demo. I have 3 very brave volunteers that have said they will help me with this. So let me just quickly check that it works. Yes, OK, cool. So the model just say I'm 99% Hoi. So let's try with the 3 volunteer what they say. So if you just stand kind of just behind the scarf on the thing and then press A, kind of look into the camera. And the lowest one will win a prize. OK. 99%. Oh, wow. OK. Try again. 99% again. Oh, my God. OK. Let's see if we can get less than 99%. 99%. Oh, my God. We have joint winners. So a little prize that you can share afterwards. It's a part of the German flag. And I thought it was like quite cool. Thank you for the volunteers. So I can reassure you that it doesn't always show 99%. Sometimes it will show something like 75. Sometimes it will show 86%. So what happened? What went wrong? So in this Hoi or not demo, what went wrong was basically my bias sample. So in the training model, I thought, hey, I've got 60 photos of me, which I search on Google Photos and put it into a folder. And then in the other folder, I basically put all the different flowers from the TensorFlow Colab. And I thought, hey, that will be enough. Is Hoi or other? But it turns out that when I actually look through those photos, only 30 out of the 3,000 odd photos have people in it. So the model isn't so much telling me from other people, but the model is telling between me and flowers. So unless you look like a flower, it's not going to say other. So when it's Hoi or not, in reality, this is not to scale, by the way. This is what it is, because I am just a tiny speck of dust in the entire universe. And when you say or not, then basically you have the entire universe on the other side. And as a result, when you look at the machine learning challenges that you have when you're training something like this, it's immense, because you need to collect all kinds of different samples. You need a rabbit, you need a cat, you need to recognize all kinds of different classification in order to do this. So if you're trying to do something or not, be careful. So here are 3 other things I've learned. The first one is really practical use of customized model is try to control your environment in terms of both input and also the kind of circumstances you're taking. So for example, if you're in a production line and you're trying to tell between apple and oranges, perfectly fine. You can train a custom model to do that. If you can control the lighting, you can control the camera angle, all the better. So the more things that you control, the higher the accuracy and the quality that you'll get. Second, to make your model smaller, there is a method called quantization. Instead of using float32, you'll use an unsigned int, which is basically a quarter of the size. And in order to do that, you need to, when you're training your model, you need to insert what we call fake quantization nodes, which specify the maximum minimum, so that at the end of your training process, there are some hints as to what kind of range the unsigned int should cover. And for more detail, search for fixed point quantization for more detail. And final and third thing, because I basically hacked this together in very little time, and one thing that I realized is some of the Colab that you'll find online are built for float-based models. Some of them are built for unsigned int model. And when you mix the two, they're just not happy. So for the first one, you will see that the model is basically expecting a float model, which is 4 times the size, or the image to be 4 times the size than the one that I'm actually specifying. So when that happens, you look at your code and say, hey, am I feeding in a byte array that is full of float, or am I feeding in a byte array that is full of int? So that's the first one. And then once you get the first one, the second one wasn't so obvious, because once I get over the first one, the second one say, oh, you are still basically using the wrong type. And I go, no, I'm pretty sure they're feeding the correct type. And what this second error actually means is if the model itself is float, when it output the confidence matrix, it will also output it as float. And because the matrix I was feeding in wasn't accepting float, that's why it crashed. So the second one was less obvious to me because I keep on checking, oh, my input is correct, and I didn't realize that the output array that I was trying to fit in was the wrong type. So overall, the number one thing is still put, regardless what you hear about how hot ML is, first thing first is like putting the user experience first. If you're thinking about deploying ML in your product, think about how it will make it different. Think about how it will make the user's journey better. And then the second step is I would strongly encourage that you use what is there. Even though that you think, hey, maybe I can train something better, I need high accuracy, I would still strongly encourage that you use what is there and then see whether the user journey actually works and say, hey, if I can detect an orange, would that improve the user experience? And work with your UX researchers to really kind of optimize the user flow. And then third and finally, customize only if necessary, because there is a lot of work that goes into a lot of these models, and if you don't have the compute power, the resources, the expertise, and the data, then it's really difficult to actually get to a position where it's accurate enough for your use. So that's it. If you have any questions, just come and catch me. Thank you.